We doing math today. Ain't got time for no games. We doing math today. All work and no play. We doing math today.
Hey guys, let's go over the introductory video for rewriting radical expressions. All right. We've done some things in here. So here there is a couple of things. There is nothing there, but they call this the index. They also call this the root. And again, let me see if I can... if you see no number here, so no index, this would mean that this number here is, call it n. N is equal to 2, which they call a square root, right? This symbol we've already talked about. This is the radical. And inside, we've already talked about, oops, I went in red. This they call the radicand. So a way of writing the this definition here is that the radical is a way of writing the nth. And let me change colors. The nth root from up here. So again, the variable n will just turn into a number. Of a number. Okay. All right, let's get some more information here. Well, that's the basics one. So let's add on to this now. So this is called rational exponents. And with rational exponents, what is a rational exponent? A rational exponent, let's just call this RE. A rational exponent is just a fractional or fraction exponent. So for example, there's my root, and let's say I have an x here. The big idea is that this, what degree does x have? That is 1. So notice how that 1 will kind of stick by, and it's going to be over the n power. So I'm basically going from a radical sign to a fractional exponent. Okay, so let's write some information here. The exponent under the radical, which is the radicand, becomes the numerator of the rational exponent. So here is the 1, and it becomes the numerator, the top of the fraction. Okay? The index, what is the index? That is the one here in red. Where does that go? Becomes the denominator. That's the down part of the rational expression. So that n comes down. And how I like to remember it is that 1 here just stays right next to the x. And the n goes down to the denominator. Let's do a couple of examples, and this might make sense to you. So I have okay, so again, this is the, let's do some highlighting colors, that might help, right? So we said the exponent, the green will stay on top, okay? Let's highlight that. And we said the red is going to go on the bottom. Okay, let's do it for that. Let's do this for a couple examples here. So I have the x. Actually, let's move that further down. And the green, the inside goes on top as my numerator, and the index, the red, goes in my denominator. So this is a rational expression. Okay, let's do the same thing over here. I have an a. I have a big A here, and that number there is an 8. And did you guys notice how I'm writing my fractions? I call it up and down fractions. Do not do something like this. Don't do that, okay? But I'm trying to show you guys that I'm up and down fractions, vertical fractions, and there's no number there. Remember, we talked about that. There's no number. It's a, what, 2. And here you can simplify. 8 divided by 2 is actually a 4. So a to the 4th power is how you would write that one. And the last example here in C, well, you have this big letter here, a B. Well, what's the number in green there? If you don't see one, that's actually a 1. So this would be 1 to the 9th power. Okay? All right. And that's all I have for you guys. Let me double check something real quick. Make sure they don't do any negatives, or you guys will encounter some that have the index isn't the same. So this is a good example. Let me do B again. Use color here. Okay, so let's just say you have a to the 4th, and you have a bunch of stuff that has like a 3 to the 2nd. Actually, I shouldn't do a. I should do a different letter. Let's do like a x to the 3 halves, y to the 4 halves here. And let's just say you just have this 4. Well, to make it a fraction, you by putting it over 1, and you want denominators of 2, so you just multiply by 2 over 2. So you would get, this would become 8 halves. So in the beginning, let's just say you're going to face this problem, you might have something like this. And you'll notice that each of those have a denominator of 2. But this one doesn't. Does that make sense? So you would just make it over 1, multiply by 2 over 2, which gives you 8 halves, and then you'll notice that now that all of them have a denominator of 2. Okay, so that's my introductory video for 3.14a. Guys, let's go over A1, and we need to rewrite these each as a rational exponent. Remember, when you think of rational exponents, just think you need a fraction as an exponent. Fraction. So over here, this one's a little bit tricky in that there is no number for the index, and we talked about in the intro video that is a 2. So you can write these separately. Now the first one, I like to put the inside the radical, this 3 becomes the numerator and the index becomes the denominator. For the y variable, it's y to the first power, and then again the index becomes your denominator, and this is your answer for A1. Let's move on to A2. You can separate them if you want, so you can see it. And this last one is c to the 5th. Okay. Remember, the inside, the radical becomes the denominator, and this index is your denominator. Let's do the same thing here. It already says b to the 4th, so there's my b to the 4th, and that 3 there goes in the denominator. And the last one, the c has a 5th degree exponent, and the index becomes your denominator. And this would be your answer for A2. Let's move on to A3 here. Remember that number, the 4, becomes your denominator. So f to the 3rd, you see that? Remember, you're writing your fractions up and down. And then g to the 6 over the 4. So g to the 6 kind of stays, and you just put it over 4. Now, you need to also reduce if possible. So this one will become, essentially you're dividing it by the same number, which is a 2. So that will become g to the 3/2. Because remember, that's 6 is 2 times 3, and 4 is 2 times 2, and those 2's are canceling, and you're left with 3/2. Don't forget to box your answer. This one is your answer for A3. Okay, A4, this one you have to be careful. It has a plus sign. All that means is you're just keeping these parentheses together. Okay? So I'm going to write out this in yellow. So I still have the x plus y, and it has a power of 2 from inside the radical. Remember, the index becomes the denominator, and this is your answer for A4. For A5, this is a fraction, and I'm just going to put all of these. I'm going to separate it. You don't have to, but you kind of see it better, I think. Remember, it's to the index of 3. Remember that s has a exponent, and that is a 1. And then you have, again, index of 3, t to the 4th power. And let's just go ahead and write this down. So again, I have r to the 2nd, and that denominator is 3. The s to the 1st power, but the index becomes my denominator, which is a 3. And then here we're going to have t to the 4th power, but again, the index is 3. And this would be our answer for A5. A6, do the same thing. This is, oops. I like to rewrite it, a to the 5th. And remember, you see no number there. The index is a 2. B to the 2. Now, the b also has an exponent of 1. So this will become a to the 5th and that 2. And this one will be b to the first power, and then the denominator is 2. And this is our answer for A6. And then let's move on to A7. Okay, here we have a fraction. So let's just, in blue, I have x to the second over to the 4th root. And this one is in the denominator, so I'm going to keep it down there to the 4th power. Okay. So again, I have, the reason why I write equals, I'm just kind of saying that this expression is equal to the next one, and then our next one is equal to this one. Okay? So I have x to the second and my denominator of 4. Okay? And then the division sign, this will be y to the 3rd power. And don't forget its index, which is 4, which becomes the denominator. Now in this one, hopefully you're pointing out to something that needs some simplifying, is this one right here. 2 times 1, 2 times 2, 2 divided by 2 is 1. So your answer is going to be x to the 1/2 divided by y to the 3/4. And this would be our answer for A7. And the last one, A8. Again, I have 32, so I'm going to do 32 to the index of 5. And over here, I have this one to the f to the 4th. Okay, so we haven't counted a number, but is there a number, and identical numbers, when you multiply by itself 5 times equals 32? And you can put that into the calculator and just think about it. Let's see if I can show you guys with the calculator. Graph in Calc 83. Let's see. Math. Yeah, number 5. So I'm going to press 5, math, number 5 on mine, and then I'm going to type in 32. Press Alt, and you're going to get 2. And you can check that because the inverse of that is 2 to the 5th power, 32. So we're going to have 2 times f to the 4th power with the index of 5, and this is going to be our answer. And that was questions A 1 through 8.